A fraction of the children is sitting. 5/7 of the children are sitting on chairs. If a pizza pie is served at the party and the pie is cut into 8 equal slices, then each slice is a part, a fraction of the pie. Each slice is 1/8 of the pie. If the birthday cake is cut into 12 equal slices, then each slice is a part, a fraction of the cake. Each slice is 1/12 of the cake. Fractions are not only found at birthday parties. Fractions are also found everywhere. Think of how you use fractions every day. Each time you read a page in a book, you are reading just a part, a fraction of the book. If the book is 96 pages, each page is 1 of 96 of the book. 1/96 of the book. Coins are fractions too. There are 20 nickels in a dollar. Each nickel is a part, a fraction of the dollar. Each nickel is 1 of 20 nickels in a dollar. Each nickel is 1/20th of a dollar. Now you know some fractions. You know 3/10, 5/7, 1/8, 1/12, 1/96, and 1/20th. Let's see if I can read upside down. Take a look at 3/10, the fraction of balloons that are red. The 3 tells you we are talking about 3 red balloons. The 10 tells you that there are 10 balloons in all. Take a look at 5/7, the musical chair fractions. The 5 tells you we are talking about 5 children. The 5 who are sitting. The 7 tells you that there are 7 children in all. Take a look at 1/8, the pizza slice fraction. The 1 tells you we are talking about 1 slice of pizza. The 8 tells you we are talking about 8 slices in all. Each fraction has a top number and bottom number. The top number of a fraction is the numerator. The bottom number is the denominator. In fraction 3/10, the numerator is 3. The denominator is 10. In the fraction 5/7, the numerator is 5. The denominator is 7. In the fraction 1/8, the numerator is 1. The denominator is 8. Numerator over denominator. Numerator, vinculum, denominator. Remember, the vinculum is the proper term for the fraction bar. What happens when the numerator or the denominator changes? What is 5 of the balloons at the party? What if 5 of the balloons at the party are red? Then 5/10 of the balloons are red. 5 is more than 3. 5/10 is more than 3/10 of the balloons. What if the 6 of the 7 children in the game of musical chairs are sitting? Then 6/7 of the children are sitting. 6 is more than 5. 6/7 is more than 5/7 of the children. What if you are 2 slices? What if you ate 2 slices of pizza? That sounds good right now. If you did, you ate 2/8 of the pizza pie. 2 slices are more than 1 slice. 2/8 is more than 1/8 of the pizza. The large top number of a fraction, the larger the numerator, the larger the fraction. When the denominator, the bottom numbers, are the same. At the birthday party, what if the pizza pie was not cut into 8 equal equal size slices. What if it was cut into 10 equal size slices? Because more slices were cut from the pie, each slice would be smaller. Each slice would be 1/10 of the pie. The fraction 1/10 is smaller than 1/8 of the same pizza. At the birthday party, what if the cake was not cut into 12 equal size slices? What if it was cut into 15 equal size slices? Because more slices were cut from the same cake, each slice would be smaller. Each slice would be 1/15 of the cake. The fraction 1/15 is smaller than 1/12 of the same thing. The larger the bottom number of a fraction, the larger the denominator, the smaller the fraction when the numerators, the top numbers, are the same. Folded sheets of paper and crayons can teach you about numerators and denominators. Here's a sheet of paper that has been carefully folded twice and then unfolded. The two creases divide the paper into 4 equal sections. Each section is 1/4 of the paper. Take a sheet of paper and fold it so that creases divide the paper into 4 equal sections. So take a piece of paper. Find you a piece of paper. If you need no talking. If you need a piece of paper, go get a sheet of scratch paper. Jareen, stop walking in front of the camera. Walk around, love. Thank you. And I need you to stop talking so that I can continue reading. You get one for yourself and have a seat. Thank you. This does not require reading and talking. Take a look at the red and blue sections. The red part, 3/4 of the paper, is larger than the blue part, 1/4 of the paper. 3/4 is more than 1/4 of the same thing. The larger the top number of a fraction, the larger the numerator. The larger the fraction when the denominators, the bottom numbers, are the same. I ask you to get one sheet of paper. One. Follow directions. Stop talking, please. Please have a seat. Take another sheet of paper. So using your same paper. Take another sheet of paper and carefully fold it in half. Then unfold it. There's a crease in the middle of the paper. The crease divides the paper into 2 equal sections. Each section is 1/2 of the paper. Now shade one section 1/2 of the paper with your pencil. Next, look at the 2 papers. Pay attention to the blue and the green. Pay attention to the blue and green sections. The blue section, 1/4 of the first sheet of paper, is smaller than the green sheet, 1/2 of the second sheet of paper. 1/4 is less than 1/2 of the same thing. The larger the bottom number of a fraction, the larger the denominator. The smaller the fraction when the numerator, the top numbers, are the same. That's like a little tongue twister down there. You can play tricks with fractions. If a birthday cake is cut into equal size slices, each slice the same. But 1/12 of one birthday cake might be more than 1/12 of another cake. 1/12 of a larger birthday cake is more than 1/12 of a small cake. 1/12 is more than 1/15 of the same cake. But 1/12 of one birthday cake might be less than 1/15 of another cake. 1/12 of a small cake might be less than 1/15 of a large cake. Sometimes the same fraction has different names. Take 2 white paper plates. Just listen. Take 2 white paper plates. Let's pretend each plate is a birthday cake. Before you cut the cake, you decided to serve 1/2 of it at the party and save 1/2 of the cake for later. With a ruler and a pencil, draw lines to divide each plate in half. With a crayon, shade 1/2 of each plate. That's the half you will save for later. On one plate, divide it again until you have 12 equal sized plates. Take a look at the second plate. What was once 1/2 is now 6/12. 1/2 and 6/12 are really different names for the same fraction. It would be the same if you saved 1/2 of the cake for later or ate 6/12 of it. 6/12 of a cake, one person eating that, that's a lot of cake. Now think of pennies and nickels. 5 pennies are 5 1/100ths of a dollar. 1 nickel is 1/20th of a dollar. But they're each 5 cents. 5 hundredths is the same as 1/20th. They are just different names for the same fraction. 8/8 looks like a fraction, but it's really a different name for the number 1. 12/12 looks like a fraction, but it's really a different name for the number 2. Think of a pizza pie that has been cut into 8 slices. Each slice is 1/8 of the pie. If you ate all 8 slices, 8/8, you ate 1 whole pie. That's why I don't buy dozens of donuts, because I eat how many donuts are in a dozen? 12. And if I eat 12/12 donuts, what does that really mean?
You ate the whole thing.
I ate the whole dozen. So that's why I don't buy donuts by the dozen. Okay? Listen. Shh. Think of that birthday cake that has been cut into 12 slices. Each slice is 1/12 of the cake. If you ate all 12 slices, you ate 12/12 of the cake. If you ate one whole cake. That sounds like me and those donuts, right?
Yeah.
These different names for 1 will help you find different forms of fractions. What happens when you multiply any number by 1? The number you start with and your answer are the same. The numbers you start with and your answers are the same. That's also what happens when you multiply fractions by 1. The fraction you start with and your answer are the same. 6/6 is a different form of 1, so 6/12 is another name for 1/2. You can find lots of different names for the same fraction. Just multiply the numerator and the denominator by the same number. Just multiply the fraction by 1. Can you find 5 different names for 1/2? Can you find 3 different names for 1/3, for 2/3? Think about fractions. Once you know fractions, you can work with them. You can add and subtract fractions, which is what is coming up in Unit 2. To add fractions, when the denominators, the bottom numbers, are the same, you simply add the numerators, which are the top numbers, and write your answers over the denominator. At the birthday party, if you ate 1 slice of pizza, you ate 1/8 of the pizza. If you ate a second slice, you ate 1/8 more of the pie. You ate 2/8 of the pie. 1/8 plus 1/8 equals 2/8. Each eighth is represented by 1 slice of pizza. If you ate 1 slice of birthday cake, you ate 1/12. You ate 1/12 of the cake. If you ate a second slice, you ate 1/12 more, or 2/12 of the cake. 1 slice plus 1 slice is 2 slices. But 1 slice represents 1/12. So we have 1/12 plus 1/12 equals 2/12 of the birthday cake that you ate. Understand?
Understood.
To subtract fractions when the denominators are the same, you simply subtract the numerators and write your answer over the denominator. At the birthday party, if you ask for 3 slices of pizza, you ask for 3/8 of the pie. If you ate just 2 slices, you ate 2/8 of the pie. You would have 1 slice left. 3/8 minus 2/8 equals 1/8. 3 slices minus you ate 2 of your 3 slices equals you're left with how many slices?
1.
1 slice. At the party, if you ask for 2 slices of birthday cake, you ask for 2/12 of the cake. If you ate just 1 slice, you ate 1/12 of the cake. 2/12 minus 1/12 equals how much? 2/12. 2/12 minus 1/12 equals
1/12.
Good job. So you started off with 2 slices of pizza. You ate 1 slice of pizza. So how many slices do you have left?
1.
Awesome and amazing. You guys are awesome and amazing. I love that you're focused and not fidgeting with paper. I love that all computers are closed. All computers are closed, except for that one. Fractions are at birthday parties. Fractions are at football games. Fractions are in shoe stores. Fractions are in clothing stores. People use fractions to tell time. People often use fractions. Fractions are everywhere. The end.